afternoon, everyone. We heard about the hero already earlier today, but what happens when the hero can become a villain? So there's a quote from the movie The Dark Knight that says, "You either die a hero or you live long enough to see yourself become the villain." And this portrays really well the story that I'm about to tell today. When a viral infection happens, after that, the virus is cleared, the lung will keep a few immune cells locally to protect against a future threat. Those cells are called tissue-resident memory cells. Resident because they live there permanently, and memory because they're able to memorize, to remember the threat. When we're young, those cells can recognize that threat really fast, and they have all the tools to eliminate really well. So in this way, they go to a hero mode where they can provide a fast protection and a better recovery. So basically, when our lungs are young, the guards will do their jobs. However, with age, even when there's no threat in the lung anymore, those cells feel that something still doesn't feel safe. So they keep recruiting more and more cells, more of those memory cells to the lung, where they can actually go to a villain mode. Because imagine if in this room suddenly 10,000 people goes here, it would be chaotic. It's the same thing in our lungs. So when we have too many cells, the lungs are actually not able to recover properly. So they go to villain mode, and the lung cannot recover. Those cells are not evil. It's just that the environment around them changed, so their behavior also changed. What does this happen? Every cell needs a fuel to stay healthy. It's like a car. If you don't put gas, the car will not work. One of those cell fuels is called NAD. And when we're young, we have plenty of this fuel, but with age, the levels of the fuel is decreased. When we have a lot of that fuel, our cells work properly. They can do their job. But when they don't have enough of that fuel, they feel that something's wrong, so they keep calling more and more cells. We observe in our research with mouse models with the flu that another detail I forgot to mention, with age, there's another thing that happens that contributes to that. The cells increase a molecule called CD38 on their membrane, which acts like a faucet controlling the amount of fuel that cells can receive. And we observe that in aged mice with the flu, the cells have way more of that molecule, which may push them from a protective to a harmful behavior. What happens if we remove this faucet and replenish the fuel back for the cells? Can we push the lung to recover faster? And this is what we observe. We observe that when the older mice get the flu, their lungs are pretty much damaged. We have a lot of disease in their lungs. But when we treat with the blocker, when we remove that faucet and put more fuel, we actually have an improvement of the disease. We also observed reduced numbers of those harmful cells. As we can appreciate in the red, we have way less harmful cells in the mice that receive the treatment, meaning that we can actually control how those cells could behave. And this results into a better lung function. When we get the flu, the ability of our lungs to expand and contract is compromised, as we can appreciate in the blue. However, when we treat the mice, the ability of breathing is restored. So the main message I want to bring today is that if we control the behavior of those cells and control how many of those cells we can actually keep in that lung and preventing the hero from becoming a villain, we may be able to help older adults from recovering faster and better from a severe viral infection. We want our memory cells fighting the virus and not the lungs. Thank you very much.